Hello, this is Mr. Collier, and today we're looking at the volume of 3D shapes. So let's take a look at some names of shapes first of all. We got triangular prism, hexagonal prism. You can name prisms just based on the shape of their base, I guess. And then we have the cylinder, which also works similarly to a prism. It's got like a uniform cross section, so it's very similar to the prism as the base area times the height. All these formulas are given in your formula booklet, so you don't have to worry too much about them. And we also have the formulas for a pyramid and a cone. Alright, let's get into it. So for the volume of a cylinder, you can merely look it up in the formula booklet. The formula for by the way, they have some formulas under prior learning, and then some of the more advanced formulas are on the next page, considered perhaps new learning. Okay, so we have a cylinder. So the cylinder formula is where is that is in prior learning, is it? Okay, the volume of a cylinder is pi r squared h. So write down the formula first, pi r squared h, and it's simply given in the question. So this one's a pretty easy one. You can type that in and round to three significant figures. That'll give us 94.2. It is a volume, so you're going to have cubic centimeters. Okay, and the next one, we've got party hat, how much candy can fit in it. Well, this is a cone shape. The cone formula is in the next page. It's 1/3 pi r squared h. So volume equals 1/3 pi r squared h. We've got inches and centimeters here, but let's use centimeters because this is also given in centimeters. 1/3 times pi, the radius, the diameter is 13.4. So the radius is 13.4 divided by 2, which is 6.7. So we're going to use 6.7 squared times height, which is 21. So let's type that into the calculator. So let's see, 1/3 times pi times 6.7 squared times 21. Okay, that rounds to 987, but that's not our final answer, so we don't need to round it actually. Let's use that exact number to answer the question, how many candy can fit in there? So number of M&Ms is going to be this number, 98718. That's cubic centimeters. We can just divide by 0.65, and that'll give us our answer. So let's take the exact number on a calculator, just press the divide button. See, that didn't work for some reason. Try that again, divide by 0.65, and it'll give you about, now to three specific figures, that's 1520. 15, you get around this number, that's the third significant figure, so it's 20 M&Ms, I guess. Let's just leave it as that. Okay, next we have this shape. They give you basically this cross section. They give you all this information, so you can find the area of this triangular cross section, and they give you the height of the prism is 15. Let's look at the formula booklet for a second. So it says volume of a prism is area base times the height, so we are going to get the area of the base first, and we can use our simple area formula. Volume equals half times 12 times 12 sine 130. And actually we can just stick all those numbers directly into this formula. So volume equals half times 12 times 12 times sine 130 times the height of the cylinder is 15. Make sure you get this angle in brackets though, or it might try to multiply the 15 by the angle and that'll mess everything up. So you just merely type all that in to your calculator and round it, and you get 827 cubic centimeters. Okay, and the next examples, we've got a pyramid and a cone. The pyramid formula is in the formula booklet. It's not under prior learning, so we got to look at the next page. Right angle pyramid, 1/3 area of base times height. Okay, so the volume here equals, let's put down here, volume equals 1/3. Area of the base is 4 times 3.5, and the height is given. Sometimes we got to use Pythagorean theorem to find the height and stuff like that. So if you put that in your calculator and round it, you get 34.5 cubic centimeters. The next shape is a cone. It's very similar to the pyramid formula, but it's 1/3 pi r squared h, because the area of the base, is a circle, pi r squared. So we're going to use that formula. Volume equals 1/3 pi times the radius squared times the height. We don't know the height yet though, but we can find the height because this is a right angle triangle, and we can use Pythagorean theorem. So I'm going to subtract 3.2 squared from both sides and then square root. So we're going to have 11.5 squared minus 3.2 squared. Let's type that into the calculator. So shift root 11.5 squared minus 3.2 squared, and we get 11.04, and etc. We're going to use that exact number when we do this calculation here. So it's, let me escape that, 1/3 times pi times 3.2 times, copy and paste the answer from before, and we get about 37.0. Oh, I think I forgot the squared. Oops. It's pi r squared. So let me try that again. Yes, it's 118 cubic centimeters. Okay, one more example. We've got a cylindrical case with 3 tennis balls. The diameter of each tennis ball is 6. Find the area or the volume of the space in between. So there's space in between here. Well, each diameter is 6. So that means the height of the whole thing is 18. And the radius of each ball is half the diameter, so it's 3. The volume of the space is just the volume of the cylinder minus 3 times the area of one of the spherical balls, right? So the volume of the cylinder, let's write that, cylinder minus 3 times volume sphere. So the volume of the cylinder is pi times the radius squared times the height. And then the volume of the sphere is 4/3 pi times the radius cubed. And then there's 3 of them, so I'm going to multiply that by an extra 3 because there's 3 tennis balls. Okay, we can type all that directly into our calculator, and we get the volume is about 170 cubic centimeters.